So in Canvas, you are going to find a module called Midterm Exam Information. Should be in front of you now, okay? This one here, I'm going to click and it's going to tell me a PDF, or it's going to tell me that Canvas isn't ready yet. And it's working. Oh, great. Okay, that makes life easy. So a lot of what I'm going to say is in this, and you can go and read it yourself. So you don't need frantically write things down. Our window is 2 hours, starting right now at 11 and finishing at 1. So that's a 2-hour midterm exam. 146 is going to cover all these topics. I'm pretty sure now that I won't be doing some of chapter 8, but we'll see how that goes. We're on chapter 7 today, and we'll definitely need tomorrow to finish it. So I might only be doing the intro to it, and that's fine. If we do that, the intro is a pretty short one, so we can cover that on Friday. Then, when you are doing your midterm, it's important that you show all the working that you can possibly show me, right? Now, there are going to be a lot of questions where that's not possible, right? There are going to be questions where Salt does it all, right? So you just do it in Salt and you write down the answer. Totally okay with that. But there are going to be other questions where you could show me, for instance, if I went and said to you, is this number an outlier? Couldn't you do the mean plus 3 standard deviations and show me it was bigger than it, right? There'd be questions with some working. So whenever you can, try and show me working. And the reason why I want you to do that is because I can give you partial credit. So if I see working, I can tell what you've done. And if I find out you forgot to multiply something by 2, Margaret, I'll be able to see that and I'll be able to figure it out. So that's important. Now, what are you allowed and not allowed to? You are allowed to use your TI-84. You are allowed to use SALT in WebAssign for those questions that use it. And you are allowed to use any notes that you've got. So if you've got some printed notes to help you, use them. You are not allowed to communicate with any human being. Obviously, you can't phone a friend or talk to your brother. You're not allowed to go and send emails to people or contact tutoring or do searches online or go to help sites or anything, right? So I guess I could simplify it by saying, if it isn't physically written down on a piece of paper in front of you, or if it isn't in your head, you can't use it, right? Now, you're allowed calculators and all that other good stuff. Now, you will find that on Monday, when we do the midterm, that all of WebAssign will have disappeared. All the homework, all the tests that you've done won't be visible. What will be visible is part A, I think I called it, yeah. It's going to be part A of your midterm exam because it's in 2 places. The first part is going to be in WebAssign, just like an online homework. And those are the questions where I'll put things where you had to go and use SALT. You know, you use SALT to calculate standard deviation. You would use SALT, you know, to do regression lines and all that stuff. So those questions will be there, right? And you can use SALT and everything that you want in those questions. And then once you've finished that, you should then go to Canvas, and in Canvas, you'll get part B. And part B is probably where you're going to show almost all your working. And in those questions, you'll be given things that you'd be like calculating probabilities. Do you know how when we did probabilities, it could be 14 plus 10, take away 2, all over 52, that kind of stuff, right? So you're going to show me the working and probability. That would be a good example of a question where you would do that, right? And there's, I believe there's 100 points. Yes, there are 100 points from one and there's another 100 points from the other. So it's a totally 200 points. Let me pause there. Any questions about what I've said so far?
Will both parts A and B, will they be in chronological order?
Yes. So A, week 1 stuff will be at the beginning, right? Questions 1 and 2, and week 5 stuff will be at the end, you know, questions 7 and 8, whatever. And the same is true in the PDF that you're going to be doing on the Canvas site. So when you go to Canvas, you'll click on it and there's a PDF that'll appear just like this writing, only it'll have the questions. And you'll just write down the answers with the working. And once you're finished, you'll then upload it into Canvas. I'll show you how to do that in a minute. Now, here's a couple of things that you have to be aware of. This midterm is testing what you know. It's not testing that can you go and find stuff that you didn't know or forgot, right? So when you're doing a whole load of notes, and nothing wrong with a whole load of notes, if you have to look up everything, then you're going to run out of time. You just won't be able to do it. So you may have a lot of notes, but I suggest strongly that you have, as someone in my previous class went and said, he has like his little Cliff Note version, where on only in a few pieces of paper, you put the really good stuff, right? The stuff that you know you're going to need or remember, you know. Off the top of my head, does anybody remember what the upper and lower boundaries are for testing for an outlier? Right, if the answer is no, maybe that's a good thing to write down on your piece of paper so you'll know the next time, right? You might have other things there. It's up to you what you feel is really important and have them easy to get. And then you might have the rest of your notes there, but you're only going to have to go to them occasionally. I mean, if you have 20 pages of notes, do you know how long it's going to take you to sift through them to find the bit that you need? That's going to kill you on time. So try and make sure that most of it is in your brain. Now, when you're finished, you're going to use, I suggest, this program, but you can use others. Basically, and you'll see it in a few minutes, as I keep saying, it's an app you put in your phone and you take pictures of your work and it turns it into a PDF and then you can upload it into Canvas. That's how I get to see your work. Now, this is a biggie. Some people, more than others, have been using extensions to prolong the time that it takes to do their homework. There are no extensions for week 5. So come midnight on Sunday, the door closes. Any homework you've not done is gone. Any online tests, well, you wouldn't get an extension for them anyway, is gone. And I'm kind of doing this and it sounds cruel, but there's a good reason for it. If you haven't done the homework by the end of week 5, you're not ready for that midterm, are you? So I'm kind of forcing you to do your homework. So at least you'll have seen some of the stuff and you'll be a little bit better prepared for your midterm. So that's the reasoning behind it. You only have until Sunday midnight to do all of the homework, right? So make sure it's done, and that's the close off date. I think I mentioned earlier that everything in Canvas and in WebAssign will disappear on Monday, except for the midterm exam A in WebAssign and the test part in Canvas. So let me leave that and return back to some of the things I promised. Right. Get this out of the way first. There is the link that you will use. So it won't be the class link. This is the link that you'll use for your midterm. Now, Microsoft Lens. If you have an Android, there's the link. If you've an Apple device, here is your link. And here is a video that shows you how to use it. Right, you've done your homework. You've done all your good stuff, right? You click on this fella here then. And you go start assignment. This is, right, so you've taken pictures, you've uploaded it on your phone or you put it on your computer, whatever. You click on that. You do upload file, choose file, and you choose whatever your file is called. You press open, and then you do submit, and that's it. So if some of what I've talked about today is a lot to take in, can't you just go back to this video and watch the first 10 minutes? Right, so you can get a refresher. Now, when you have finished everything, right, and you've uploaded it and you're ready to go, don't leave yet. Tell me you're finished. I will go and look, and I will be able to tell you if everything's okay. Most of the time, it's going to be, yep, you are good to go, bye-bye. But sometimes I might say, I don't see any answers to question 5. Did you forget it? And you'll go, oh, oops, I did it. I just didn't copy it. Or, oh, I didn't. Yeah, I'll go and do it right now, right? Or I can't read it because it's so faint, in which case I'll say, do you want to try it again? Maybe change the lighting, put on light or take a light away. And once I can read it, you are then good to go. And if you're finished half an hour early, great. You know, have a coffee. I'll pause here. Any more questions up to where we are? Okay. Now, when you come into Canvas, come on, come back home. This one here called midterm exam information is the only one that will be visible, right? All the usual stuff like these guys here, that will not be visible. And there'll be an extra one here, which will basically be midterm exam B. And when you click on it, that's where the PDF where your questions are. Right now, I've put it here for convenience. If you click on this one, here is a practice to kind of show you what one of my midterms would look like. For instance, in these questions here, how many others? God, there should be about 30. Yeah, there we go. These are multiple choice questions. What that means is there's one answer. And so for these questions, typically all you would tell me is that the answer is C or the answer is A. And I wouldn't expect working for those. There's a multiple choice. On the other hand, here are questions where you would actually physically have to do stuff. So let me zoom to what the answers look like. For instance, you might get to build a bar chart or a histogram, or a 5-figure summary from scratch, including drawing a box and whiskers, or creating a stem and leaf, or back-to-back stem and leaf, or calculate Z-scores.
Is the actual exam going to be 24 pages?
Oh God, no. No, this is like 5 times more stuff than you're going to do, right? Plus, there's a lot of solutions here, right? So these are just examples of the kinds of questions you get. So for instance, here we're looking at probabilities, right? And it's just a practice. You can choose to use it or not. It's just something. That, of course, will disappear on the day of the midterm as well.
Is there an answer key for the practice exam?
There is. The solutions are there. So it is there. Yeah.
So is this the study guide? It's like, if you know that, you'll do well on the test, or is
Not
it
quite.
like beneficial to go back on the prior exams that we've taken?
Yeah, it's helpful, but it's not comprehensive. There are questions that are going to be in the midterm that are not in that practice final. So you really want to look at all the online quizzes, right? Online tests that you've done as well.
Okay, awesome. Thank you.
Okay, are we good? Can we start next now? Any questions? Okay, we are now going to do calculating, evaluating probabilities. And we're going to look at, started writing these down, probabilities of 2 events, one after the other. there are two situations. One is called without replacement. And the second situation, where you do two or more events, is called with replacement. So let's look at probabilities of two or more events happening. First one I'm going to do is without replacement. And that's very often the phrase that they use in the homework, right? Replacement. So I'm going to do a visual one. Imagine you've got a bag, and in this bag, there are 5 red and there are 3 green beads. And we are going to do probabilities involving picking a bead out of this bag. So imagine the bag, you can't see it, you stick your hand in and you pull out a bead. Now the first question is a pretty straightforward one. What's the probability that you pick one bead and that it's green? Well, there are 3 green beads out of 8. Are you comfortable about that probability? 3 out of 8. Right. Now, I am going to do 2 beads out of the bag without replacement. And we're going to find what's the probability that the first one that came out of the bag was green, and then the second one that came out of the bag was also green. And when you do those kind of questions, they are always going to be multiplications. And so you treat the story in 2 parts. First one was green. Well, isn't that 3 out of 8? Now, because it's without replacement, you've taken a green one out the bag. Do you see the bag is now different than what it was, right? The first one has been green. So what's the chance that you now get a green? Well, isn't there only 2 green out of 7 beads? Did you see that that changed? And so the probability that you take that bag and you bring out a green bead and put it on the table, and then you go in again and, aye, another green. What's the chances of that? Well, there is the chances of that. Now, if you multiply these together, you get 6 out of 756, and I believe that cancels down to 3 over 28. And that is what that story looks like without replacement. That means whatever came out of the bag gets used up, right? It doesn't go back in the bag. Now, if you were going to do, and I want to keep them in the same thing, so I'm going to squeeze them over here. If you now do with replacement, you're going to do the same probabilities, right? So we're going to find out what's the probability that you get the first one was green and the second one was green. Well, it's going to be 2 things multiplied, right? The first one being green is still 3 out of 8. So you go into your bag, you pick it out, oh, it's green. 3 out of 8 chance of that happening. See that green bead that's in your hand? It goes back in the bag. So when you come to take the second bead, aren't there still 8 beads and 3 of them are still green? So do you see in this case, the probability did not change. And so the answer that you get this time is 9 out of 64. Does that make sense? The difference between 2 things with replacement and 2 things without replacement. Are we comfortable about the calculation? So let's keep with the beans and do 3 because there's no limit. And to save me having to write so much, what's the chance that you get a green, and then the third one's a red? And we'll do this one without replacement. So it's going to be, well, probability times probability times probability. Do you see when you do three things, you multiply three probabilities, right? Now, this one is, the first one comes out the bag and it's green. Well, we've done that tons of time. It's 3/8. Now, since it's without replacement, don't we now have a bag with only 7 beads in it? And there's 2 of them green. So the chances that the second one is a green is that. Now, when time you come to the third one, haven't you already eaten or used up 2 greens? Do you see the bag is now only got 6 beads in it? And how many of those are red? Ah, there's 5 red out of 6. Are we good? Right, now, that's just not worth me trying to do in my head. So here goes. I'm going to do 3/8 in brackets times 2/7 in brackets times 5/6 in brackets. And then math number 1, make me a fraction. And the answer is 5 out of 56. And if they wanted to know the answer as a decimal, it would be approximately 0.09. Or 9% chance of that happening. Right, now that is without replacement. Same event, but this time with replacement. So each time you take the bead out the bag, you look at its color, and then you chuck it back in the bag after you're finished. So it's still going to be 3 probabilities multiplied together. Okay, anybody want to tell me what the first fraction is, the first probability? That's getting a green right off this, right at the beginning.
3/8.
Yeah, I'm giving you the easy one. What would the second one be green, given that it's replaced, right? It's put back in the bag.
Same thing.
Yeah, same thing. What's the red for the last one going to be?
5/8.
5/8. When you compare the two, do you see the dissimilarities, how they're not quite the same, right? Now, in this last one, putting brackets around it, 3/8 times another 3/8 times a 5/8. And then math choice number 1, and 45 512s. You comfortable with that? Now, you see that calculation I just did? There's the same calculation without brackets. Do you notice the answer's not the same? So will you make sure that if you're doing this, that you put brackets around each multiplication, right? Each fraction, you see it? 3/8 bracket. Otherwise, that might look correct to you, but order of calculation kicks in, and I'm not even sure what the order that TI-84 is doing that. What I do know is it's not doing it in the order I wanted, right? Because it's not the same answer. So a little hiccup, but you know, little things like that can cause you problems, right? Now, the good news would be if this was your working, and then you wrote down, you know, 1/9 or whatever that wrong answer was, wouldn't I be able to say, yep, she did it right. Okay, she screwed up somewhere in the button pressing, but I know she was doing it the right way, so you get points. If you just wrote down, well, what is this guy as a fraction? If you wrote down 15 128ths, but that's all you wrote down, do you see I can't help you? I can't give you points because all I know is Oh, it's the wrong answer. I don't know what she got the answer from. She never showed me the calculations that she was doing, right? You see where I'm going with this? Right. Now, if this was a WebAssign question, because it could be a WebAssign question, shouldn't you show me the working, even although you're putting the answer into WebAssign? Because I could still give you partial credit as long as I can tell what you were doing and what you were doing was right. So far, so good? Right. So we have this idea that you can do something more than once. And we've got attached to that idea that you can do it with replacement or without replacement. So let's do it with cards, because that's my go-to guy. Dice questions don't really lend themselves to this, so I'm not even going to do dice questions, but I will do cards. What's the probability that you get 2 kings? And we'll make the assumption here, unless the question tells us otherwise, that this will be without replacement. Would you agree when you deal a card, you give me a card, I keep it, right? I don't say, oh, thank you, and I'll give it back to you, and then you shuffle them and give me it again, right? That's very unrealistic, right? So in card games, aren't you going to really be dealing with without replacement? So that means we're going to have to multiply 2 guys, obviously, 2 kings. What's the chance that the first one is a king? So imagine a full deck of cards. There's 52 of them. And how many of those 52 cards are kings?
4.
Okay, so the first card is a king, right? So you got it in your hand, and now he's dealing you the second card. Try and imagine you're in this story, right? I got my king. Oh, very good. Now he's giving me the second card. How many cards are in the deck?
51.
And how many of those 51 are kings? Only 3, correct? Does that make sense? Have you noticed that you kind of reduce by 1, reduce by 1? Have you noticed that pattern? The number on the bottom becomes 1 less, and the number on the top, at least if they're the same thing, becomes 1 less. So let's put that into the calculator and go 4 divided by 52 times 3 divided by 51. And I get that guy, and I'm going to do a math 1 fraction. And I get as a fraction 1 over 221. It's not uncommon with these questions that you turn them into a decimal and then you round it off. So as a decimal, 0.0045. As a percentage, nothing 0.45%. That's less than 0.5%. So if you were playing a card game and somebody dealt you 2 kings, because kings are good to get, isn't that a very hard thing to have when you have a good hand? So let's suppose I deal you 3 aces. You know, in the movies, when the guy gets dealt 3 aces, doesn't he typically get shot by the cowboy at the end or something, right? So we're assuming that this is legal, right? It's not pulling them out of your sleeve. So we are going to find 3 probabilities, again without replacement. The first ace, there are 52 cards in a deck, 4 of them are aces. The second ace is a little bit different. There are only 51 cards in the deck, and there's only 3 aces. And then the third ace, there's 50. And of those 50 cards, there are 2 aces. Are you comfortable about that? Now, I'll try that in the calculator and we'll see what happens. 4 divided by 52 times 3 divided by 51 times 2 divided by 50. Now, I'm going to hit enter in a second, but let me tell you right now, that is like, if you've ever played a game of cards and somebody dealt you 3 aces, you would remember it, right? Isn't that like, whoa, look how lucky I am. So There is the answer. Do you see it's got a funny e to the -4 on it? Say hello, e to the -4. I'm going to write down most of what that says. I'm rounding it off a little bit to that. I'm now going to try and see if the calculator can make it a fraction. Math, number 1, enter. It couldn't handle it. Do you see that? It couldn't make it a fraction, which is why these questions are very often given as decimals, right? They know you're not going to be making a fraction out of it.
Mine says 1/5525.
Yeah, that's what I got. But I did mine by hand.
Yeah, if you did it by hand, you'd be able to get it. You're right. I mean, if you wanted to do it that way, and it's possible, couldn't you do 4 times 3 times 2 and get 24? And then 52 times 51 times 50, and you'd get that fella. And then couldn't you cancel it down and get your answer? But the chances are you're going to be asked to do these as decimals. So if they want decimals, you can't give me a fraction, right? You have to give it in the form they want. This is scientific notation. This means 1.81 times 10 to the -4. That guy there is him. That's just how TI-84 writes times 10 to the -4. And that again is not the answer we're looking for, because in a real world decimal, it's that guy. Do you remember how to take scientific notation and turn it into a decimal? And you're only going to be dealing with -2s and -7s, right? That's the guys you're going to be dealing with. Here is a very shortcut way of doing it. If that says -4, start with 4 zeros, including the 0 point. And then just rub out the decimal point. Does that make sense? This is just a shortcut way of doing it. Write down 4 zeros and make the decimal point. Technically, you are multiplying by 0.0001, and that is where it comes from. But if you tried that, your calculator would just end up telling you that again, and you'd be no better off than you were probably. Are we cool with that? Now, if I turn that decimal into a percentage, I get 0.0181%. That's like 1 in 5 or 50,000. I think it's
1 in
1 in
5,525.
right. So you'd have to play an awful lot of games of cards where somebody dealt you 3 cards, right? An awful lot before you would ever be dealt 3 aces. Do you see that this technique now allows us to put probabilities on things happening? Right. Now, there's a game called Blackjack. And if you get an ace and a king, it adds up to 21. But let's just do it. What's the probability of being dealt right out the game? An ace is my first card and a king is my second. Right. So first card is an ace. Okay, there's number 1. What is the probability of the first card being an ace?
4 out of 52.
Agreed. Now, what about the second card being a king? Right, there's only 51 cards left now because the first one was an ace and we didn't put it back in the deck. What about the second one?
4 out of 51.
Right. So you see the numbers are the same this time, right? Not 4 times 3, but 4 times 4 again. So in this case, let's see what we get. 4 out of 52 times 4 divided by 51. I'm going to just keep the decimal version of this. And the answer is 0.006 to 3 decimal places, or 0.6%. Are you good with that? Now, Technically speaking, that is considered a different event. This is the first card was an ace and the second is a king. This is the first card you got dealt was a king and the second is an ace. And I'm doing this one very quickly because I know what the answer is going to be. It's also 0.006. We call that blackjack, right? Or one version of it at least. There's ace and queen and ace and jack also count, right? But in this case here, if I wanted to know what was the chances that I got two cards, one was an ace and the other is a king, but I didn't care which way it happened, right? So I didn't care if it happened this way or that way. Then all you would do is add these together and that would be their probability. Does that make sense? So I wanted to know what's the probability of an ace and then a king. I don't care which one's first or second. Well, you find out the two things that could happen and you are done. Are we good? Now, again, let's do a different story and let's do babies. The probability that a boy is born is actually about 0.51. You would have thought I was going to say a half, right? 50% chance in boy, 50% chance as girl. But actually, boys get born a little bit more often than girls. Does anybody actually, that is true, but did anybody know that? Anybody in a biology class or whatever might have been told that, but it is true. As far as I know, don't quote me on this because I could be wrong about why it's the case, that boys and girls get born at different proportions depending on factors such as the age of the mother. So if the mother has a child, if the mother is having a child and she's later in life, and later just might mean, you know, early 30s, late 20s, they tend to have more boys than girls. Something to do with just the genetics. And if you have a child when you're in your younger, like you're 21 and 22s, you tend to have more likely have a girl than a boy. And because in America, at least, isn't it true that you tend to have your children later in life? You know, your late 20s maybe for your first one. Not everyone, but, you know, in general. That's the encouragement. Now, if I tell you that is true, even if I don't tell you what the probability of a girl being born is, can't you still tell me what it is? What is the probability of a girl being born in this story?
0.49.
Exactly, right? Now, in these questions, we're going to consider them as with replacement. Now, it doesn't mean that after the baby's born, you stick it back in the mum. It just simply means that one probability does not get changed as you go through. So, if I wanted to know what's the probability that I have two children and both of them are boys, because it's without replacement, you can simply just multiply the two probabilities together and they will not change. So you can use this shortcut formula. And for a boy, that's 0.51 times another 0.51. And these are all going to be decimals. So I'm going to go 0.51 and, oops, the answer I get is 0.26. Let's say they want the answer to two decimal places. So there's about a 26% chance that you get two boys. Now you can extend that. Suppose you have 5 kids in your family. What's the probability that every single one of them is a boy? I am not going to write any more questions this long way. But would you agree that all you do is multiply the same thing 5 times? Now, in this case, 0.51 times 0.51. Again, this is the only time I'm going to write it out this way. Isn't there a nice shorter way of writing that? Don't you write it like that? Would you agree that writing this and this is a very cumbersome way of saying that? Now you go to your calculator into 2 decimal places. Let's see how likely that is. So the 0.1, there's the power button, 5. I have to 2 decimal places. So if you could find all the 5 children families, say in America, right, just families with exactly 5 children, about 3% of those are all boys. Just curious, does anybody want to share, doesn't need to be 5, but share a story? I know a family with 4 girls in it, or I know a family with 6 boys in it. Does anybody know anything like that?
I have a cousin on my stepdad's side who's part of 10 kids. 9 of them are boys. The last one's a girl. And then my
Whoa.
husband has a cousin who has 5 boys and then also 1 girl at the very end.
Right, so it happens, right? In fact, according to this data, won't it happen about 3% of the time? So it's not like, you know, if you know 100 families with 5 children in them, 3 of those families are probably all boys, right? And couldn't we also calculate all being girls, right? That's equally doable. Isn't it, because it's without replacement, isn't it just a matter of multiplying the things together? Now, I can make the question a little bit, not a lot, but I can make it a little bit different by saying, what's the probability that you have 2 children and you get 1 of each? Right, so you have a family of just 2 kids and you get 1 of each. And, well, 1 of each would be a boy and then a girl. Would you agree? But couldn't it also be the first one was a girl and the second one is a boy? And don't they count as 2 separate ways for that to happen? Right, a boy and then a girl is not the same as getting a girl then a boy. And if you add them together, that's how you find out the probability of getting 1 of each. Does that make sense? A boy and a girl, or a girl and a boy. That's 1 of each. So this one is the probability of a boy times the probability of a girl. So this is 0.51 times 0.49. And that's going to equal whatever the calculator tells me it's equal to. So 0.51 times 0.49. And I'm doing to 2 decimal places here. So that ends up being 0.25. And a girl and a boy, well, probability of a girl times the probability of a boy. It's actually the same 2 numbers being multiplied. You just switch the order. You agree? And so since it's the same 2 numbers, you're going to get the same answer. And when you add them together, oh, it's kind of pretty. So if you looked at all the 2 children families out there, about 50% of them, right, which is what that is, about 50% of them will have a boy and a girl in it. It seems actually quite reasonable, doesn't it? If you think about family sizes, 1 of each is pretty common. Oh, to share your story that Cheyenne was doing, one of my sisters, Morag, I was going to say successfully, but that's not the word I'm looking for, wanted a girl. And she successfully managed to get 4 boys. And then she gave up, right? So she wanted the girl and she got a boy. She was happy, loves it, and whatever. And then she said, well, we'll try for a second child. And, I'm going to get a girl, right? No. And the 3rd one, no. And the 4th one, okay, that's it, no more. So she gave up at 4. 4 boys she got. And just to show you the perverseness of genetics, all our boys are married now and have their own families. And every single one of our 4 boys, the first child that they had was a girl. Just the weirdness of genetics. I don't know why. In fact, there's no reason why, isn't it? There's a lot of luck involved in getting a boy and a girl, right? It's just the way it happens. Are we getting comfortable with this kind of more than one thing happening? Right. So we're going to look at one last example of that. And let's say the probability that it rains in any given day is 0.3. And the probability that it doesn't rain, so I'm just going to call that dry, is 0.7. And we are going to look at without replacement. In other words, probabilities do not change, right? That's another way of thinking. For instance, in the boy and girl one, I said that is with replacement, I should say, right? The probabilities don't change, right? They would describe these something like the probability that it rains on any given day is independent of any other day, right? So the probability you get a boy is independent of, you know, the next child being a boy or a girl, right? Each one is separate. They have no interference with each other. Now, the first one's a pretty straightforward one. What's the probability that it rains 4 days in a row? Now, wouldn't that be 0.3 to the power of 4? Can't we do the shortcut rather than write down all those 0.3 times 0.3 times 0.3 times 0.3? And in this case, we get 0.3 to the power of 4. And the answer that we get here, I'm going to have to change my rounding off to 4 decimal places, right? That's fine. And now the weird question. What's the probability that it rains, here's the fancy word, at least once in 4 days? Now, if you ever see a question where it says at least once, then you're into this very special situation. Now, you could say, well, I'll just write down all the ways in which it could rain at least once and find the probability of them and then add them all up. And if you did it that way, apart from taking you about 4 hours, it would work. But we're not going to do that. We are going to use a guide that we've only really touched on, and this is where it comes into its own. We're going to look at the complement event. So if I call this A, right, that it rains at least once in 4 days, isn't the complement of A the exact opposite of that? Now you have to do a bit of logic here. What's the exact opposite of it rains at least once in 4 days? Because it could rain once, twice, 3 or 4 days, right? What's the opposite of that?
Does that mean you have to times A times 4 dry days?
So in English, it's dry for 4 days. I'm just paraphrasing what you said, right? Does that make sense? The opposite of raining at least once in 4 days. The opposite of that is that it was dry for every single day. Right? Now that in our story then means dry, 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 dry. And that becomes 0.7 to the power of 4. So here we go, 0.7 to the power of 4. And that is equal to 0.2401. And you might say, well, you found that answer, but that's not the answer I wanted. I didn't want to know the opposite of this. I wanted to know this. What do we know about a probability and its complement? Isn't there a property that connects the two of them? Don't they always add up to 1? So the probability of what I wanted, which is A, is just 1 take away the probability of its complement. So all I really need to do is take that away from 1 and I've got my answer. And my answer will be 0.7599. Was that not a sneaky way of getting that answer? Not getting the answer that I was being asked, but finding the exact opposite probability, right? Its complement. Because that's easy to do, right? 4 days in a row is easy. Getting at least 1 rainy day isn't. It could be rain, dry, dry, dry. Dry, rain, dry, dry, right? And that's only with the singles. Couldn't you then do rain, rain, dry, dry? Dry, oh God, I'd be here all day repeating them, right? Trust me, there are tons of them, right? That would be a horrendous way to do it. But the opposite of raining at least once in 4 days is it's dry for all 4 days. That's easy to do. And then you just say, well, that's not what I want, but it is the complement of what it was. So if I take it away, I've got the guy I'm looking for. Cool. Right, last name, bye-bye. And we're finished for today. I'm going to make gamblers of all of you by the time this part is finished. Okay, up you come. Up you come. There you go. She wanted a little attention. Okay, any questions for me, River or Brandy, before I leave? No. So bye-bye. Maggie, bye-bye. Okay, I'll see you in a few moments.